All right, so chain rule, you're going to chain on the derivative of 3x, which would just be 3. And then you just take 3x and plug it in. So if you square 3x, that would be 9x squared, and then plus 5. You're not doing a derivative, you're not doing an antiderivative, you're not putting plus c, it is none of that, because derivative and integral cancel each other out. You're just plugging in. There was a little bit of a chain rule, but that's really it. All right, for this one, for y equals 2 plus that thing, find the derivative and state the initial condition. All right, so first let's find our derivative. So what is your derivative of 2? Oh, we're on the non-calculator part. This is non-calculator. There is a calculator section, though, where you are going to type a bunch of stuff in, but we're on the non-calculator right now. All right, so derivative of just plain 2, guys. It'd be 0. You did the antiderivative. I know, it's hard, all right? But that's just 0. And then when you do the derivative of this, it's really similar to what we just got done doing. Derivative of 4x would just be 4. And then you're going to take 4x and plug it in for t. So 4 cubed, you guys know that one, right? All right, so you have 64 and then x cubed, you just make it negative. And then it says state the initial condition. You can write it as an ordered pair if you want, but usually you see it as y of something equals something. And you don't always need to plug in 0. 0's not going to be helpful in this case, because if you plug in 0, you get integral 4 to 0, and I don't know what that is, okay? Instead, if I plug in 1, and trust the process here, if you plug in 1 for x, you get integral from 4 to 4, which is nothing, plus 2 is 2. It's a multiple choice question, so you'll have choices to look at, okay? But did you get what I was saying there? If you plug in 1 for x, this integral is 4 to 4, which is precisely nothing. And then 0 plus 2 is 2. All right. Let f of x be this accumulation function. Your accumulation starts at pi over 6, which I know you're all excited about. What is an equation for the tangent line? All right. What 2 things do you need for an equation? Right. Point and a slope. So it's going to be pi over 6 comma something, and then we'll get our slope. I have good news for you. If you plug in pi over 6, that's really simple, because what do you get? 0. The integral from pi over 6 to pi over 6 is nothing. You accumulated nothing. All right, slope comes from derivatives. So let's get our derivative. You're doing a derivative of an integral. You're doing the derivative of the integral, exactly like we did for, so it's just sine of x. Derivative and integral undo each other, all right? And now you have to plug in pi over 6. I'm going to just throw it out there. Does anyone know what sine of pi over 6 is? The side that goes across from pi over 6 on your unit circle. If you were with me, this is how I teach it. Here's pi over 6. What goes across from that? I heard somebody say it back there. It is 1/2. What goes on the other side? Good, but that would be cosine, so I don't want this. He fixed it. All right, so you're going to take your point and your slope and write your equation. It would be y minus 0, which you don't really need to write that, equals 1/2 parenthesis x minus pi over 6. All right, number 4. The graph of that thing is shown. Oh, where does the accumulation start? -1. So right here, this is where our accumulation is starting. On, oh, this is sticky note stuff. I love these. On what interval is g of x decreasing? There's actually 2 of them, and we'll have to union it together. Good, -4 to -2, union 2.5 to 4. You don't need a justification because it didn't ask you for one. These are multiple choice questions. All right, what is the value of g prime of 2? Well, first let's find g prime. If you do the derivative of this, the derivative of this thing right here, it'd be f of x. And then if you plug in 2, well, this is the graph of f of x. So f of 2 is, yeah, 1. I agree, right there. We haven't found any areas yet. I feel like that's coming, isn't it? Oh, no, it's not. We aren't even going to need to find any areas. At what x value is there a relative minimum? Negative to positive, so good, -2, like the hot air balloon problem we just did. Sweet. That was not very much work. That was like all sticky note stuff. I like that one. All right, let f be this thing. It's an accumulation function. Accumulation starts at 1. On the interval 1 to 3, is f increasing or decreasing, concave up, concave down? All right, for increasing and decreasing, you need your first derivative. So let's get f prime. What is your derivative of this thing? 5, good, minus. Yeah, square root of x squared plus 12. Good, perfect. All right, and then I would plug in 2. Why would plugging in 2 be a good choice? Yeah, and it'll make that be a perfect square, but it's in the interval is what I was thinking, all right? So if we plug in 2, we're gonna get 5 minus square root of 16, which is 5 minus 4, which is 1, and the point is that that's positive. So increasing or decreasing. This is bigger than 0, so increasing. All right, and then the second part of that, concavity, you need the second derivative. So we're going to do the derivative of this right here. So derivative of just 5, gone. All right. Oh, who remembers the derivative of square root? Perfect. It's 1/2 square root of that stuff. Good. And then you chain on, so I'm going to put it in the numerator, the derivative of that stuff, which would be 2x. Now there's one thing I didn't put, the negative. Good. The negative is sort of just there. I don't have a better explanation than it's just there. If you want to cancel out those 2's, you can or not. That's like personal preference if you want to do that. And again, I would plug in 2 because it's within the interval that we're looking at. Just going to finish this one, then we'll do our break. So the numerator would just be -2. The denominator would be square root of 16. The point is, though, that that is negative. So that tells you that your graph is what? Concave down. Perfect. So this is asking on what intervals your function is decreasing. Think about your sticky note. Decreasing is where your derivative is negative. Good. Okay, so we're going to find the derivative. We'll make some number lines and put in our pluses and minuses and find where it's negative. So what is your derivative of this integral? Yeah, just stick x in there. -2x squared plus 6x plus 8. Now I would divide out the -2. That would give you x squared minus 3x minus 4. I'm going to kind of go quickly through this part because this is algebra 1 here, all right? Then you're going to split that. It'll be x minus 4, x plus 1. Now, a lot of times I just get rid of that number that's out front. I had to keep it this time, though, because it is negative. If it was positive, you could just throw it out. But since it's negative, or you could throw it out, but then whatever you get at the end, just do the opposite. That's kind of up to you, however you want to do that. I'm going to make a number line for my -2 and just put negatives the whole way across. Again, the other thing you could do is throw that out, but then whatever you get, just make sure you do the reverse of that. However it works in your brain, right? And then you got x minus 4, that's going to have a change at 4. And x plus 1 would have a change at -1. And then how do you fill them in? Yep, negative to positive. And then you can draw your little balloon strings. So what's the overall sign for the first section? Negative, good, and then it's gonna alter. Positive, negative. All right, so we were asked decreasing, that's where your derivative is negative, so how would I write like my final answer? -infinity to -1. Union, yep, 4 to infinity. Good. Again, it'll be multiple choice. You have to stop that now. This next one is kind of weird to do without choices. Like what you would do is just test each of the choices until you get one that works. So it's kind of weird without choices, but I took them away for the review. So if this is your function And F is positive and increasing. So what does positive mean? Above sea level, increasing means going up. So I would just draw a quick graph that is positive and increasing. Where does the accumulation start? 1. So here's 1. I'm gonna kind of like dot that in. It says, what's a possible table of values? So if you make a table of values, if you plug in 1, what will you get? Good, why 0? Perfect. 1 to 1 is 0. All right, so any of your choices that doesn't have a 0 there, you throw out those. Now, if you want to go backwards, so like if we go back to 0, you're accumulating backwards. So what's like a potential, we're just gonna make it up. Yeah, well, I would make it bigger than -1, like, let's make it like -3. We'll go with that. Now, if you plug in 2, that means you're going forwards. It does mean it needs to be positive. However, because this function is going up, I couldn't make it -1 or -2. Do you see what I'm saying? It has to be a bigger area than what you said for this one. So what's a potential number that would, yeah, 5, 4, 5, something that's larger. Do you get what I'm saying? It's multiple choice. So what you'll do is just like look at the choices and see which one makes sense. That's a weird problem to do without choices there, right? Water is being heated up according to your function C of T, time is in minutes, temperature is in degrees Fahrenheit. What does this thing mean? All right, what is the C of 0? Oh my gosh, you even used the right vocabulary. Initial condition, good. That's the temperature of the water to begin with, which is at time 0. What is this? So there's a word that we use and it begins with D. Displacement. So if you take where you started and you add on how much you got displaced, what do you get? Where you ended, oh, perfect, where you ended up. So this is the temperature at what time? 12. Do you see 0 to 12? It's the temperature at 12, was it minutes? And I guess it would be temperature in degrees Fahrenheit at 12 minutes, you know, just the temperature you ended up with. You took where you started, you added on your displacement, that's just where you ended up. Good, cool. I thought I was gonna have to pull more teeth in that. That was nice job, guys, perfect. All right, the rate at which students finish their calculus tests in students per minute is given by this thing. How many students finish during the interval 0 to 30? If your brain said, oh, that's an integral 0 to 30, congratulations, your instincts are good. All right, it's 0 to 30 of this function. So we got to find areas of some shapes. How would you split it up? Would you do a trapezoid or would you do like a square and a triangle? You hate trapezoid. Okay, well, so the square is 4. This triangle would be 3. Oh, wait, it's not 4. I'm sorry. I didn't look at the scale. Yeah, it's actually 20. Oh, my bad. No, it's not 20. It's 100. I believed you. I believed you and everything. All right, yeah, because each square is 5 by 5. Okay, so this is 1 here. I'll write it out. 1/2, the base is 10, and the height is 15. So 75. And then for this large triangle, 1/2 base times height. What's the base for that one? 20. And the height is 25. $250. Oh gosh, can we add all that together? 425 students. Yeah, I didn't mean to make it that much. I'm sorry, guys. My bad. Yeah, I'm really sorry, guys. I didn't realize it was that many. It's a big class, you know. Oh, I'm recording this.
He asked where the 4 came
All right,
from.
moving on.
75 plus
Here's the other thing you could have done. You could have found the areas like I started to and called this 4. Do you get what I'm saying? And then just multiplied by, well, I guess you'd have to multiply by 25 at the end, 5 by 5. Anyway, at time 0, particle starts, it starts at rest. 0 velocity. No velocity to start with, starting at rest. Moves with an acceleration given by this. Through how many units does the particle move during the first 2 seconds? What you want to do is integral 0 to 2 for velocity. The problem is we don't have velocity. We were given acceleration. Oh, but we can get from acceleration to velocity by doing what? Good. Antiderivative. Antiderivative of this. Well, you would raise it to the 4th. And then you'd have to divide by 4. So 10. Good. And then you just work that out. So your antiderivative of that, you would raise it to the 5th power, divide by 5, 2, good, such that 0 to 2. And basically you just need to plug in 2. It's upper boundary minus lower boundary, but 0 is just going to give you 0. So 2 to the 5th, does anyone know that one? It is 32. Double that is 64. Good. And I don't think there were units. It just said units. Cool. All right. A particle moves with acceleration given by that awful thing. Position is 8 at time 0 and position is 14 at time 1. What is the initial velocity? This is one of these ones where you kind of just have to start with what they give you and like see where it takes you. Okay. It's kind of like they gave us all this information. Let's just see what we've got. First of all, I'm going to rewrite that acceleration as 9t to the what? You guys are awesome with fractions and they're negative. You guys are good. All right. Then I would go to velocity. You're going to add 1 to the power. Conveniently, that'll take it from -0.5 to +0.5. And then you'd need a 2 out front, be 18. Now you have to actually put plus c on that. That's the answer. Whatever that c value is, that's what we're looking for because we want the initial velocity. Are you following me there? I know, don't go to sleep. I know we're like very hungry. Wait, question? No.
Sorry.
Oh, no, are you sure? Okay. This is our answer. Okay. Let's take what we have. Oh, I can't yet. I need to go down to position. All right. So we're going to go to position. We're going to do another antiderivative. If you add 1 to a half, you will get 3 halves. That means out front, you'd need a 2/3. Gosh, 18 times 2/3, was that 12? You'd have plus CT plus, now it would be another constant, but I don't want to put another C on there. Oh, why is it 8? I thought you said 8. Oh, well, I wouldn't just, I thought you said 8. Well, 8, why? That's the position at time 0. Okay, nice save. I thought you said 8. 8 is what you're going to put there. Okay, now what we're going to do, we're going to use that other piece of information. At time 1, your position is 14. So we're going to plug in 1 and set it equal to 14. All right, I promise it won't be as bad as you think because 1 is an easy number to work with. What's 1 to the anything? 1 times 12 is 12 plus C times 1. C plus 8 equals 14. And then you just solve that for C. So what 12 plus 8 is 20. So -6 is your answer. You have to be like a detective for that problem. You're like, I'm taking all these clues and putting them together to find the thing.
Oh, why do you put a T on the position?
We did an antiderivative. So like pretend C is -6. Then it would be -6t. We're used to seeing it with X. So with T, it looks weird. All right, here, my goal is to finish 12 and then the next page before lunch. I think we can do it. All right, again, this is another one that's weird to do without choices. On the test, you'll have choices. Draw a velocity graph showing a particle being furthest to the right at time 5. All that means is that at time 5, you need a lot of positive accumulation. So you want to draw something that's above sea level until 5. If it says draw a velocity graph showing a particle farthest to the left at time 5, that just means at time 5, you want a lot of negative accumulation. Again, it's going to be like this. out of the following choices, which one is furthest to the right? And you're gonna pick the one that is the most above, or it says which one's furthest to left, and you're gonna pick the one that's the most below. That's all that that is. All right, it's just weird to do it without choices. All right, this is our free response one. Free response are cumulative. They pull from everywhere. Okay, I also made a mistake in my graph. Well, not a mistake, but this part right here should not be there. The interval begins at -2. I'm trying to white it out, but my whiteout is like, no, I have some, it's just not working. Or it's operator error. Try to ignore that little piece of the graph. Do you get what I'm saying? The interval starts at -2. So let's read. This is the graph of f prime. You want to be like, yes, they gave me the derivative. That's your source for everything. All right. Then they also give us all the little areas of these regions. The first one it says is 15. You see where I'm getting it there? Now it says the next one's 7, but we're gonna put -7. The next little bump is 2. And then to here, I'm gonna just connect this down. The last one is 6 for that one. You don't even have to find areas of any shapes. How nice is that? I just gave them all to you. It's great. And they do that sometimes for non-calculator ones. All right, find the x coordinates of critical points. Does it say justify? Don't. It's timed test. All right, what are the critical points? -2, 1. Good. That's literally it. Move on to the next one. Identify the critical point that is the location of a relative maximum. Now this one does say justify. So you want to start your sentence, f of x is or f of x has. So good, f of x has a relative, what did it say, maximum? At x equals what? Good. Because, beautiful, f prime changes or switches, whatever you want to say, from positive to negative there. Ladies and gentlemen, this is why I drill you and drill you and drill you on these justifications, is so that when you get there and it says justify, it doesn't scare you at all. That is the answer. I can't change it. It's a definition. All right. Find the value of f at the x coordinate identified in part B. I need to go back and find where we started. Like I need an initial condition somewhere, and they actually give you 2. You have to pick which one you're going to use. So let's look at the first one. Do you see how it starts at 0? I can't start my accumulation at 0. Why not? Well, how does that 15 break apart in there? Do you see what I'm saying? So I can't start at 0. So I'm not going to use that one. I'm going to use this one. So my initial condition is 3. It's going to be 3 plus integral from 4 is where it's starting. Are you guys seeing what I'm pointing at there? All right. From 4 to where are we trying to get to? Yeah, this is not going well. Why is it 1? That's it says the x one that you found in part B, which we found it was 1. I need to recap that. Can you all just stop and watch me point to that? All right. Do you see how it was 3? 3 plus. Do you see how that was 4? It's 4, and the reason it's 1 is because it said to use the number from part B. Okay, f prime of x dx. Yeah, now the answer is really easy. You just go back to your graph. It's going to be 3 plus. Now we want to accumulate from 4 to 1. From 4 to 1, you're going backwards. So it's +7, and yeah, 3 plus 7 is 10. Absolute extremes. What test is that? Candidates. There's kind of a lot of them. But they're easy to find because they gave you all the areas. All right. So what are they? -2, 1, 4, 6, 8 is the end of it. I know it kind of didn't do a very great job making that. I need to write that a little bit nicer because I take a picture of this and post it. So I need to make it look a little bit. What was it? 4, 6, and 8. We found 1 already. What did we get for 1? 10. Now you have to do the same exact thing. Look at what we wrote right here. It's going to be 3 plus your integral from 4 to whatever. Okay, so let's do -2. It's gonna be 3 plus, we wanna go from 4 all the way back to -2. So it would be +7, -15. Good, -8. So 3 minus 8. So -5 for that one. 4 is easy. If you plug in 4, it would just be 3. 3 plus 0, so just 3. We're finally moving in the positive direction here. 3 plus your integral from 4 to 6. 5. 3 plus 2 is 5. And then the last one is going to be 3 plus 8 is 11. Oh, you just did it in your head. All right, now absolute maximum is, what's the biggest number we got? 11? As you're saying it faster than I can write it. Is 11 at x equals 8. Absolute minimum is -5 at x equals -2. Sorry, say again. It says extrema, which is both. That's like the plural of extreme. Extreme is singular extreme. Extrema is many extremes. I didn't make the rules. All right. On what intervals is f decreasing and concave up? This is your sticky note thing. Decreasing means the graph is below sea level or negative. I'm just going to write a little note. Concave up means the graph that we are looking at. Oh my gosh, you guys are awesome. All right. So where is that happening? I think 2 to 4 is it. All right. So 2 to 4, because f prime is negative and increasing there. I didn't have to pull any teeth on that one. I'm super happy. All right, these are some review questions. We do this before lunch? When's our lunch? Oh, I have enough time. We'll finish this one and then you'll get like a little bit of a breather before we go to lunch. And we'll do the calculator part after. Explain by there must be a value of c from 0 to 4 such that, is that f, no, f of c equals 3.5. Hold on, did I mean to make that f prime? Oh, no, I didn't. Sorry, I forgot about reading the question. When you come back up here, f of 0 is 4, f of 4 is 3. The one they want us to justify is 3.5. Well, 3.5 is in between, so what theorem is it? Okay, so you're going to say, since f of x is what? Good. It is continuous. Probably like, why'd she say it? Well, I started the sentence by saying f of x. So at that point, they know which function I'm talking about. Okay. Usually you get a point for that. So that's good. All right. And then in some capacity, you have to say like this whole in between thing. So what was the smaller one? 3. So f of 4 is 3. That's smaller than 3.5. Which is smaller than what? What will I put on the other side? 4, which is f of 0. And then you will repeat this. I'm not going to write it again right now. Just recopy that by IVT. Just literally rewrite that. You don't have to do it right this second, but just on your test, just rewrite it. Cool. All right, find limit as x goes to 0 from the right, but just 0 of this. All right, what's f of 0? It says it in the little paragraph at the front. We actually used it in 4. What's 4 minus 4? 0. You have to write this. Limit x goes to 0, f of x minus 4 is 0. They make you write it this way to get all the points. It's not hard, so just do it. All right, and then do the denominator. What is that going to give you? 0. They need you to do them separately, and usually that's worth a point. So you get a point for that. All right, now what rule is this? Does anyone remember? Like an encyclopedia of calculus ever. L'Hopital's rule. So you have to link these together. Limit as x goes to 0 of the problem. Hey, Miss Cole, looks like you just recopied the problem. Sure did. Equals limit x goes to 0. And then what is L'Hopital's rule? Like, what does that mean you're going to do? Derivatives. Good. So what's the derivative of f? F prime. what's the derivative of 4? 0, don't write it. On the denominator, what's the derivative of 7x? I kind of said the answer. And then you just plug in 0. F prime of 0. I know it's been a while, that's why I labeled it. This is the graph of f prime. So what is f prime of 0? So, do you see how that's 7 right there? All right, so it's 7/7, which is 1. So usually it's a point for writing this, a point for linking these together, and then a point for the answer. Okay, one more. G is defined by that. Find G prime of 4. I actually love these ones. You just get G prime and then plug in 4, and you don't even have to simplify it because it's free response. What rule do we need? Perfect. Whoever said that. You're going to bring down the 3. It's going to drop to a 2. You leave the insides alone. And then you're going to chain on what? F prime. Yep, the derivative. Cool. And then we're going to plug in 4. What is f of 4? Hint, they told you at the beginning. Was it 3? And you don't have to evaluate that, so don't. All right, and then f prime of 3. Again, this is the graph of f prime. So what's f prime of 3? Or I'm sorry, not 3. Oh, not 3. I read it wrong. What are we plugging in? 4. I'm sorry, there were so many 3s. We went f 0. So actually the whole thing is 0, but